Welcome.
Thank you.
I'm so excited to be doing this interview. You were over here recently and you interviewed me about my trajectory in the context of STEM, and we've swapped roles here. I'm interested in hearing about your trajectory in STEM, and of course our trajectories have intersected, which is what has brought us here. And so I thought we should talk about that intersection first, and then the rest of the trajectory later, even though that would be the reverse of chronological order.
So I'm your PhD student. I believe I'm your 12th PhD student.
Yeah, that's right.
And so we've obviously gotten to know each other quite well by doing science together. We have many meetings. We've also gone on a number of trips. We go to conferences together, have gone to the telescope together. And so that's been probably one of the major ways in which you and I have gotten to know each other.
Mm-hmm.
But of course, we've also done a bit of co-teaching and co-mentoring, which has been really enjoyable. So you and I both taught at the prison teaching program at UC Santa Cruz. You took me to jail. You taught me how to get into Santa Cruz County Jail, and we got to teach algebra and pre-algebra together there, which was a really amazing experience.
I think most importantly, I got to bring you back from jail.
You got me out of jail too, yes.
I got you out of jail. And you know, I know that we've intersected on this teaching, and this time not teaching adults, not in jail, but we've taught high school students or mentored high school students in a. So I counted 3 different ways. We taught a research methods module at an all-girls school, and we then went to a different all-girls school, went there virtually because this was an all-girls school that was halfway around the world in Calcutta, in modern high school, another all-girls school, and there were a few students, 3 students and a science teacher who we took on a different kind of journey, not so much a teaching of computer programming that we did in one of the all-girls schools. And then a third kind of intersection with high school students has been where you and I have co-mentored in now 2 different groups of high school students, 2 groups of 3 high school students, one working on a project that's actually very similar to your PhD thesis,
right.
Using Hubble Space Telescope data, and a second using spectra from Keck. And so I love the fact that we've had these different that our trajectories have intersected in so many different ways. It's almost like they're going back and forth. But there was a time before our trajectories even intersected at all that I'm very keen to hear about.
So I grew up in New York City, and my parents are both professors. They teach tax law, so they're not explicitly math science people, but I think by their nature they both are math science people. They actually both had scientific degrees in undergrad. And my dad in particular is well, first of all, both my parents are very much teachers. They're professors, but they're really teachers in their hearts. And my dad in particular loves math. And so growing up, I remember riding on his shoulders on the way to kindergarten, and I would practice my 5 times tables with him. He taught me to count by 5 on the way to school. And we would do math problems when we were stuck in traffic in the car. I guess they were kind of physics problems because there were a lot of relative velocity problems, like if a river is going this fast and you're canoeing in the opposite direction this fast, when are you going to get to the end of the river, problems like that. So my brother and I would do those with my dad in the car. And so I think growing up, I obviously had a lot of access to education and opportunities and encouragement to be intellectual and to work hard in school. And so I was always good at school, and I always enjoyed school, and I loved basically everything. I loved reading, I loved history, I loved French, and I also enjoyed math and science. But that came actually a little bit later. It wasn't I was not bad at it in middle school, but I think it was in high school that I started to really enjoy science and challenging myself in science. But
was that an integrated science curriculum you had in high school, or was it a sequence of physics, chemistry, biology?
It was a sequence, except I kind of screwed it up a little bit by by skipping biology. So my high school, they've now changed this, but they actually taught physics in ninth grade, chemistry in 10th grade, and then biology in 11th grade. But I went to a very small school where they would only offer AP physics and AP chemistry in separate years.
Okay.
So I took AP chemistry as a junior and AP physics as a senior, and I've never taken biology. So it's a big weakness actually in my scientific repertoire that if you take me to trivia night and there's a science question and it's about biology, I'm absolutely no use.
Well, speaking of biology, you mentioned a brother.
Yes.
So a younger brother.
Yes, I have a younger brother.
And so he must have been inspired by this as well to see an older sibling, be, see the enjoyment of math and physics problems in an everyday context.
Yeah, it's interesting. My brother and I are very close in age, so we're only 18 months apart, but we're also very, very different. And so we do both love the math problem in the car kind of challenges. We both enjoy challenges, but we actually do tend to give each other space. And so my brother ended up actually being a history major and is now considering law school.
I see.
So his interests have diverted from mine, even though we both started in the same car doing the same math problem.
Well, I'm grateful you took so much physics and chemistry and math because you may have become a biologist, otherwise in our paths would not have intersected there.
Totally possible.
So do tell me about the transition beyond that, though. I mean, you went from there to a small liberal arts college.
Right, so I went to Haverford College in Haverford, Pennsylvania, just outside of Philadelphia. And I made that choice because I was a student who enjoyed everything. I loved reading and the humanities and languages in addition to math and science. So I really had no idea going into college what career I was going to work towards. So my first year at Haverford, I took a year of Italian, I took art history, I took an English class, and I also took math, chemistry, and physics. And it was my physics classes that I took where afterwards I just felt how I really wanted to learn more, and I could sense how much there was that I hadn't yet learned that I wanted to understand, and I didn't feel that same sort of yearning in my other subjects. Though also I have to say a major reason that I think I excelled in science in high school and also excelled in science in college was because I had fabulous teachers, and so I think one of my best teachers that I had taught my freshman physics sequence, and that was a major reason that I continued it. And he was also very encouraging to me, so encouragement from the right people at the right time definitely did a lot to shape my career.
This is freshman physics at Haverford? Or
At Haverford, yeah.
I see. That's, people are an important part of the journey.
Right, so I should maybe back up and explain how I became interested in astronomy after I started pursuing a physics major. So Haverford has this amazing course that's called the Freshman Seminar in Astrophysics.
Okay.
And they target first-year prospective physics majors with this half-credit course where you do, we call it in astronomy, an order of magnitude calculation, where you take the simplest physics that you learn in ninth grade, the physics that you apply to a ball that has been thrown in the air and is going to land. You take those same tools and you apply them to objects in the universe, which I had never given much thought to. My exposure to the astronomy was largely through the Hayden Planetarium in New York City, where I went on field trips, and I always was sort of unnerved by the whole thing. I was like, oh, that's awfully fast out there. And so it was never something that I really considered pursuing as a career until I took this course where I thought, working problems together on the board was really fun and really amazing how close to the right answer you could get on these really challenging problems about these objects that we can't even touch. They're just out there in the universe. And we also, on the last night of the course, looked through the telescope and I saw Saturn for the first time. My heart skipped a beat. It was very, very beautiful. So that was when I started, that's when I decided that I was going to pursue a dual degree in physics and astronomy. But I didn't decide that I wanted to have a career really in astronomy. There's a big difference between what you major in college and what you want to have as a career. And I decided that I wanted to pursue a career in astronomy after having courses with and doing research with Beth Willman, who is a professor at Haverford and is now the deputy director of the Large Synoptic Sky Telescope Survey. Is that right?
Large Synoptic Survey Telescope.
Large Synoptic Survey Telescope, which is, of course, one of the major astronomy projects of the coming decade. And she really was a fabulous mentor to me, really inspired me, and took me on my first observing trip at Kitt Peak National Observatory in Tucson, Arizona. And I guess it's outside of Tucson, but
close,
near Tucson, Arizona. Yeah. And I just had the most fabulous time on this trip. I was really nervous about it because I am not a person who is good at staying up late. I don't like to, there are scorpions on that mountain, and that is not my thing. I was pretty anxious about it, but I ended up having a really fabulous time. And that's when I realized that I could enjoy doing science in addition to learning about science in the classroom. And research, of course, is all about doing science, not doing problems that have answers in the back of your textbook. And so it was actually on that trip back from Kitt Peak where I was on the plane flying back to New York, and I just had a moment of clarity where I just knew that I wanted to go to grad school in astronomy. And so I paid, the $8 or whatever exorbitant cost it was for this really terrible internet that they had at the time on the plane so that I could Google astronomy programs. And I hadn't seriously considered it up to that moment. But so, Beth's amazing courses that I took from her, and as well as her encouragement as my mentor, and she really changed my life.
Wonderful.
Yeah.
Now, Beth, what was Beth's class on? It sounds like the content of the class, it was really the process more than the content that...
Yeah, it was advanced observational astronomy.
Oh, I see. So the observing trip was really part of that. But, wow. So this observing run that you paid for airline internet for changed your life. That's
that was the fall of my junior year of college. So I really didn't know, even though I'd done 2 years of the major, I didn't know really up until that point that I really wanted to go to graduate school. And then that was solidified by my RU experience. So, of course, the National Science Foundation offers these research experiences for undergraduates, it's also called REUs, that are amazing programs, and I had the privilege of doing the one at Smithsonian Astrophysical Observatory, which is connected to Harvard University in Cambridge, Massachusetts. And so there I had the opportunity to work with a new fabulous mentor, Francesca Chavano, and I got to work on a completely new project and learned a completely different set of research techniques that I also enjoyed. And so that experience really convinced me that I was on the right path going to graduate school.
And that was in the summer between your junior and senior years then? And
yes.
Oh, I see. And so that's when you're getting ready, the fall of senior years when you would apply to graduate school.
Yes.
And that, I guess, was the beginning of the intersection of our trajectories. Tell me about your graduate school applications and how that played out. And your love of French. Again, comes to the fore, doesn't it?
Yeah. So the fall of my senior year, I applied to graduate programs, and I also applied for the Fulbright Fellowship to spend a year abroad in Paris. So Beth connected me, and one of the ways in which Beth changed my life was making this connection for me in Paris with Gary Mammon, or Mammon if you're speaking English. And so he and I together put together a proposal for the Fulbright program. Okay. So my plan was always, if I got the Fulbright, great, I would go to Paris, and if not, great, I would go to graduate school. And that ended up working out really well because I didn't have to worry about the application process for graduate school while I was on my year abroad, which was really, really nice. So I applied, I think I applied to 4 East Coast schools, 4 West Coast schools, and 1 in the middle. And based on my acceptances, I felt that UC Santa Cruz was going to be the best fit for my needs as a graduate student.
And you visited Santa Cruz on that?
I did. So a really fun part about getting admitted to graduate school is that they fly you out. So you kind of do your college tour after you've been admitted. And it's nice because the schools pay for it. So I got to visit these parts of the country that I had never been, including Santa Cruz. I hadn't been to Santa Cruz until visiting, but I felt at home right away in Santa Cruz. My aunt lived in Los Gatos, and we would visit her often when I was growing up. So the moment I stepped out of the car, just the air smelled very familiar, and I was very happy. And then, of course, chose Santa Cruz for its emphasis on research and the graduate program, and the amazing graduate community and the amazing faculty. So,
and
yeah.
that would have been around the time you were also preparing for your trip to Paris then.
Right, so I hadn't yet heard when I visited from Santa Cruz. I actually found out on my visit to another school. I found out when you do these graduate visits, you often stay in homes with other graduate students. You end up sleeping on a lot of couches. And so I was in my very kind host's living room, and I get this email at 6 o'clock in the morning telling me that I'd gotten this Fulbright Fellowship. And I was, of course, extremely excited. And it was extremely early, so I was jet lagged, but I was still calling my mom, trying to talk really softly about the fact that I'd gotten this Fulbright. So that sort of then let my plans crystallize for the following year, where I was going to spend the year in Paris and then come back to Santa Cruz for graduate school afterwards.
And what was Paris like? Because you were transplanted to a new country,
yes,
new language, and in a way, possibly even a slightly different way of approaching science from the collaborations I've had with with people in other countries. It's always refreshing to see that there is something about where you are in the world, something about the society around you that is maybe causes you to think differently about, let's say, work-life balance, or how you approach science, and not just work-life balance, how you approach science, how you approach problems. Because when you have research, it's so open-ended. There's a lot of flexibility in how you could tackle these things. There is no recipe, right? By its very nature. How did you, do you have a sense of what that part of your journey, how that has broadened you as a scientist compared to sticking to one community of researchers?
Sure. So I can speak specifically to why that experience was a diverse experience for me scientifically, because as I mentioned, I went to telescopes in undergrad, and you and I together, we can talk about this more, but you and I together go to the telescope in Hawaii, and we use the telescope to take our data and to make measurements from our data that we went and got ourselves. The collaboration that I was a part of in Paris was more theory-driven. So more driven by using computers to create models to study still galaxies. I've studied galaxies most of my career, all of my career, but using different tools. So there was no going to the telescope. And I think that was a really useful experience for me in terms of learning a different approach to how other scientists study galaxies. And I learned a lot about galaxies from doing that project, and also about what I enjoy as a researcher and what I was going to pursue as a graduate student in Santa Cruz.
If you're only in a place for a year. I've had that kind of experience in my life where I was in Baltimore for exactly 1 year. I knew going in I'd be there for a year. You make the best of a place in a way that you wouldn't if you felt you were going to be there for a longer time.
Right, absolutely. So I definitely knew that I wasn't going to be in Europe for an extended period, maybe ever again. Who knows? Who knows how often one gets to have an apartment in Paris? Yeah. So I absolutely took advantage of my time abroad and had a really wonderful year. And it was also really good for me to have a break from being in school. You're in school, you're in entire life if you go straight through to graduate school. And it was my first time doing full-time research for a full year. And I think that after, I worked very hard at undergrad, and it was a real relief that I didn't know that I needed until it was happening to me, to have this break where I was just doing research. I wasn't worried about deadlines and homework and grades. I was just doing work, and that's ultimately what graduate school is like after you get through the master's portion of graduate school. But of course there's a lot of coursework in graduate school as well. So I think it was really good for me to come into graduate school with that extra research experience, that extra knowledge about galaxies, and coming in fresh after a year out of being out of school.
Your research at UC Santa Cruz is something that I am absolutely fascinated about, but I have a huge stake in it myself, so I'm biased.
Yeah. Me too.
Yeah, you are too. But do tell me about your what aspect of your research at Santa Cruz do you find the most exciting?
So my research at Santa Cruz involves studying the formation of the Milky Way galaxy by studying the motions of the oldest, most distant stars in our Milky Way. So the Milky Way is a spiral galaxy that's embedded in this huge halo of dark matter. And dark matter, we don't know what it is, but we know that it exerts and experiences gravity. So we believe that the Milky Way assembled its dark matter halo by gobbling up many other smaller dark matter halos, and some of those dark matter halos had galaxies in them. So by studying the stars that used to belong to little galaxies that are now a part of the Milky Way, we can try and understand how the Milky Way came to be the galaxy it is today.
Now, this is, of course, these are the big science questions of dark matter assembly is still a burning, the nature of dark matter and how it self-organizes
Right.
through its gravity. These are important questions in modern astronomy and cosmology. The techniques have been a lot of fun as well. You
Right.
mentioned going to the telescope with Beth.
Right.
We've had the privilege of working together in the oxygen-deprived summit of Mauna Kea, and the oxygen deprivation was not fun, but everything else about it was a lot of fun.
So I guess I should say I said I studied the motions of these stars, and maybe I should say a little bit about how I do that.
Yes, please. That would be great.
So there are three components of motion.
Okay.
One component of the motion of the star is towards and away from us.
Okay.
And the other two components are the motion of the star in the plane of the sky.
Okay.
So to measure these three components of motion, you need to use two different techniques. To measure the motion towards and away from us, we use the Keck telescope to take a spectrum of the star, where we take all of the light from the star and split it up into its different wavelengths or colors. And so we use this spectrum, we can measure a Doppler shift. It's the same technique that we experience, or it's the same effect that we experience every day when an ambulance goes by, when it is higher pitched as it's coming towards you and lower pitched as it's moving away from you. The same effect applies to stars and the light from stars. So we measure this shift to determine the motion towards and away from us
And you're saying
of
that
these different
because
stars.
light is a wave, just like sound
Yes,
is a wave.
exactly.
But, I mean, the difference is in the detailed nature of the waves,
Yes.
but that's what we're exploiting.
Right.
Now, you mentioned two techniques, even though there are three components of motion. So
Right.
the to and fro you're measuring from a Keck spectrum.
Right, but then the other two components, if you're moving in a plane, you have two components of motion to do that. And so that we measure using the Hubble Space Telescope. So Hubble Space Telescope was launched in 1990, is that right?
That's right.
Is that right?
I
So
went to see the launch, and 4 minutes before the launch, it was scrubbed, and it was launched a week later, and I got to watch it from back in Princeton. And people were very twitchy about it at the time because there had been the Challenger disaster a few years before then, and the shuttle program had been on hold for a long time. So I still remember cameras had started going, and 4 minutes before they said, "Nope, not doing this today. We're not doing this for another week."
Oh,
So I had to
wow.
go back home.
Oh.
But Hubble has changed our view of the world. I mean, our meaning not just your and mine. It's changed astronomers' view of the world in many ways. But you're using it in a very unusual way.
Yeah, so since Hubble was launched in 1990, which was actually the year that I was born, so Hubble and I are the same age.
Wow.
Now that Hubble has been up for 27 years, we can look at a picture that Hubble took 27 years ago, and we can look at a picture that Hubble takes today, and if we're looking at the same part of the sky, we can see that things have changed. So this is how we measure what's called proper motion, which are the other two components of the motion of a star in the plane of the sky, where you take a picture, you come back 10, 15, 20 years later, and you can see that the stars have moved in the image. And so we can use that information to study the motions of these distant stars.
Right. And you're using very sophisticated techniques, some of which you've developed recently, in fact. And you're working with some real experts at the institute that operates the Hubble. How's that been? Because that's actually a little bit of a departure from what we thought your thesis trajectory would be.
Right. I'm actually really glad that worked out the way it did, in part because it's always great to learn a new technique and to learn from new collaborators and to extend your network of people you work with. But also, a big part of my thesis work involved using these measurements. And initially the plan was that I wouldn't be particularly involved, but now that and people would ask me questions about them and I didn't really know the answers very confidently because I hadn't done it myself. Whereas now I really understand everything that goes into those measurements. I do them myself and I have learned from the best on how they are done, and that gives me more confidence, and I also feel like I have more control over my own thesis, which is really nice to have.
No, this is a good segue into this notion of things you learn and things you own. And this is not just true for science. I guess it's true for many things in life. There are things you learn, and there are things you can call your own because you've developed them to some extent. And you see a balance of that, right, as a scientist.
And that's, I think, a big part of graduate school, is that there's this transition. When you enter graduate school, you're usually given a project that someone else has come up with. And by the time you leave graduate school, your PhD is supposed to be an original contribution to the field. And by the time you're a senior graduate student, it happens very subtly, but you realize that all of a sudden you know the next question to ask. You don't need to ask someone what you should do next. You have your own ideas about what you should do next, where your work should go. And that's an amazing thing that's difficult to quantify, but something you absolutely learn by doing a PhD is driving your own work.
Right. Look, from the standpoint of a PhD thesis advisor, the ideal situation is for the student to go from someone who takes advice from you to someone who gives you advice about the project, because the student has now become the master of the thesis.
Right.
And it's the master's thesis, I suppose, is. But I mean, this is really true for a master's thesis. Even more true for a PhD.
For sure.
For a PhD thesis.
That's the amazing thing about a PhD, is that you become the world expert in whatever you are doing, and you are a world expert in many things, and I've learned much from you. But I have this intersection of different mentors where I am the expert in my own niche, and that's a really cool part about doing a PhD.
Look, that's one of the cool things about being a thesis advisor. It was about all the things you learn from your various quote-unquote students. They're really not your students. They're your teachers. And
they're your students too.
They're your students.
I'm still your student.
You're still a teacher. This has been... Now, you're having a terrific time doing research at UC Santa Cruz. What's not to like about the place? It's a very good department, as you said. And lots
it's a beautiful place too.
Now, but you're going to have to leave it soon, and that is another transition coming up.
Right.
And what are your thoughts about, in your ideal world, what would that transition look like? Let's say 5 years down the road, and say 10 years down the road. I mean, it's, nobody's crystal ball is clear, of course, but through that cloudy crystal ball of yours, what do you see as in your it's your optimal but cloudy crystal ball.
Right. So there are many fascinating careers that one can pursue with a PhD in astronomy, and I feel strongly that a PhD is a really useful degree to do all kinds of things. One thing that you can do is continue on the academic track. So in astronomy, if you decide to do that, what you do after you get your PhD, which is what I'm planning on doing next year, is apply for postdoctoral fellowships. So in science, in humanities, I think it's more typical where you finish graduate school and then they let you be a professor. You can have a primarily teaching position, say at a community college, on that track if you're in science, but if you want to teach at a college or a university, a four-year college, or most four-year colleges and universities, you need to have done several postdoctoral fellowships where you move to a new institution, you work with a new group, I think a lot of people really come into their own scientifically too in their postdoctoral years. So that's what I'm planning on doing next year, is applying for these fellowships to move to a new institution. And then after doing a number of years as a postdoc, you then apply for faculty positions. So I mentioned, both my parents are professors and real teachers in their hearts, and I feel kindred to them in that way, where I have always really enjoyed teaching and working with students. And so I would love that career if it works out. Another fabulous career is to get a job in the private sector in industry. You can also get positions in education and outreach organizations, like the Museum of Natural History, for example, planetariums. There are many outreach programs around the country that require people with knowledge of science to run them.
No, fantastic. Thank you so much. It's been a pleasure.
Thank you.
And off we go to Amber to eat pindi masala.